Hello everyone, my name is Amit and I'll be explaining this problem called network influence. The problem says that in a large data center there are these servers and each server performs a specific task. These servers are connected to each other with a one-way communication channel. This one-way channel says that a server can send data to another server. For example, server U is connected to server V with a one-way channel, which means server U can send data to server V. So in this network, server U depends on server V. Moving on, the problem statement says that for some analysis purpose, we are tasked with determining a measure of influence, which means for every server, we have to count how many other servers it sends data to, and then we have to sum it up and return this count. The input says that the first line contains the number of test cases t, and for each test case, the second line will contain two integers v and e. V is the total number of servers in the network, and e is the total number of one-way communication channels. The next e lines will contain two integers u and v, representing a connection from server u to server v. For each test case, we have to output a single integer, the total number of direct data flows in the network. Looking at the sample input, the first line 2 says there are two test cases. B and E are given as 4, and then the next E lines are nothing but a pair of connection between two servers. So the problem wants us to return the number of dependencies, which is nothing but total number of direct connections within this graph. So if we look at this elaborated input array, we can see that we are already given pair of edges and each pair represents a dependency. So we have to do nothing but return the total number of edge pairs. Moving forward to the solution, we can see that for each test case, we input two elements B and E. Then we create a two-dimensional array named edges of size E. And then we input all the UV pairs in the two-dimensional array as shown in the comment. After collecting all of the input, our final 2D array will hold all of the U, V pairs. And as I said earlier, a U, V pair is nothing but a dependency between U and V. So to return the total number of dependencies, we can simply return total number of U, V pairs in our 2D array. And hence, as an output, I have printed the size of the 2D array because size will be equal to total number of U, V pairs in our array. After running our C++ solution, we can see that the sample test case has been passed. For the first test case, there are 4 U, V pairs, so we print 4. And then for the second test case, there are 3 U, V pairs, so we print 3.